All right, so 4.4, we're proving triangles are similar using these three methods. Last chapter we proved two triangles were congruent and we had 5 options. Now we're proving two triangles are similar and we only have 3 options. So the first one is angle-angle similarity. We discussed that if two triangles were similar, then the angles in the triangle were congruent. Well, in reality, we only need 2 angles to be congruent. So if J and X are congruent and K and Y are congruent, from the triangle sum theorem, angle L and angle Z are also congruent. You can also call it the third angle theorem. So all we need is a minimum of 2 angles to be congruent, and we know that these two triangles are, in fact, similar. So the first one is if I have 2 angles congruent, then I have, at bare minimum, I have 2 triangles are congruent, or similar. 2 triangles are similar. So this is kind of like the shortcut. If with congruence, I don't need all 6. I just need to find the special pairs. With similarity, I don't have to find proportions all the time. I don't have to find ratios of side lengths. Sometimes I can tell 2 triangles are similar just based on the fact that 2 angles are congruent. So we can use this to talk about the angles. If JKL, angle JKL is talking about the single arc, right here, angle K. And angle XYZ, that's angle Y here. Notice how Y is in the middle and Y is the angle we're talking about. If those two angles are congruent, as well as angle X and angle J are congruent, or you could look at it as KJL and angle YXZ, then those two triangles are congruent, are similar. This is a similarity statement. Notice the little swirly line here. This means similar. We're no longer talking about congruent statements. We're talking about similarity statements. Same idea, though. You will be tested on this postulate. I will expect you to know what this is and when to put it into play. And I'll show you kind of some examples of what that looks like later. So for your first example, 4.19, are the two triangles similar? And you have to support your answer by stating the method you're using. Well, I've only taught you one method, so you only have one option so far, and that's the angle-angle theorem. So those two angles are congruent, so the two triangles are similar based on the angle-angle theorem. Now it says complete the similarity statement. Before we used to do PQR. I find PQR. That's going from no angle to 1 to 2. So I come over here, I say L has no angle mark, go to the 1, and then go to the N. So the answer is LMN. A lot of people still got this wrong last chapter, and I'm afraid they might get mixed up on this chapter. So be sure you understand you have to follow an order. So now it says fill in the denominators of the proportionality statement. So PQR and LMN. Notice how PQ and LM are in the same order, are in the same places, so that means LM goes below PQ. QR and MN, and RP and LN are on the outsides, so I put LN down below there. Now, once we get the similarity statement and the proportionality statement written, I can now start plugging in some numbers. So PQ and LM, well, that's just y over 12. And this becomes 20 over 15 and x over 18. Now, at this point, we look for filling in the blank some more. What goes under the 20? Well, that's a 15 and a y. It goes over the 12. I look over here, 15 goes on top of the 20, and x goes below the 18. I switched this one up on purpose so that you understand that's just flipping the denominator, or the reciprocal property. Instead of having 20 over 15, I make it 15 over 20. There's no real reason to do it other than the fact that it makes the math easier. So when I find x and y, I simplify my fraction, I cross multiply, and I get right here. Now I can multiply 4 and 18, and then after I've done the multiplication, I can divide that by 3. Or I can divide by 3 first, and when I divide by 3, I notice that, ignore the 4 for a second, we just look at this 18 and 3. Well, that divides to be 6. And if I can do that, then I can cross off the 18 and the 3 and just have a 6 left over. And that means that x equals 24. Either way you want to do it, this way's faster for me. But Now when we reduce this fraction, it becomes 4/3. As opposed to up here, it was 3/4. We've got the reciprocal going on for the scale factor. Now we do cross multiply, and we end up with 4 times 12 equals 3y. I divide both sides by 3. Well, 12 and 3 divide off to be 4. So I get 4 times 4 is 16, and my answer is 16. So here's your essential question. Take your time. The statement angle-angle similarity is right below it in blue. You can either, I don't want you to copy that down. I want you to use your own ideas, use your own words, but something similar to that. So for side-side-side similarity, now a lot of you are going to be thinking, hey, this is the same as the congruent statement, side-side-side, which is true. If all three sides of a triangle are congruent, then the triangles are congruent. But for this side-side-side similarity, now we're saying if all three sides are proportional to the corresponding three sides, then they're similar. So instead of having them be congruent to each other, now we just have to have them be in proportion to each other. So if you ever know all three sides of your triangle's lengths, so if you know all 6 sides in total, then you can determine if they are in fact similar using some simple reducing fractions. So you will be tested on this. I expect you to know it. Here's your essential question. How can you use side-side-side similarities to prove two triangles are similar? And again, the answer is there, but use your own words, use your own ideas. So if we look at the next one, it's side angle side. Again, you're saying, wait a second, we used that one already. It's fine, but now instead of having it be congruence, we're doing similar. So the two angles have to be congruent, and then the corresponding sides that form that angle. Notice how ZX and XY form the angle X. So that means that ZX and XY have to be in proportion to PM and MN. And if that happens, then we have two triangles that are similar. So you're going to see here we have angle X and angle M are congruent, and XZ over PM equals XY over MN. Then the two triangles are similar. Okay. This one's our third and final one that we'll be tested on. Now we can look at the last essential question. How can you use that to prove it? There's your answer. But again, use your own words, use your own thoughts, so I know that you're understanding. The triangles are similar. Find the value of the variables. So I'm telling you they're similar. Now you have to find the value of the variables. Now the reason they're similar is obvious. Angle, angle. I've got two angles that are congruent, which means the two triangles are similar. But as far as this statement goes, how can I set up P over 7 and 16 over 8? My answer would be that they're proportional, right? P corresponds to 7. Why does P correspond to 7? Well, P is in between the single arc and double arc, and 7 is in between the single arc and double arc. And 16 is next to the single arc, and 8 is next to the single arc. So I can use that to set it up. Now, how did I get from this statement here to down here? Well, it looks like the only thing that changed was that fraction, so I'd put down reduce or simplify fraction. My next step would be cross multiply. And if you'll notice when we cross multiply, we get P times 1, which is just P, and 7 times 2, which is 14. So my answer is 14. These are also on your cheat sheet. Just 3 little reminders for proving triangles are similar. Okay, so now to determine two triangles are similar, the first thing I look at is the angles. Well, do I know the measure of two angles in each triangle? Yes or no? If I do, boom, they're similar. If I don't, we'll move on. Do you know one angle in each? And if you do you know the measures of the sides that create that angle? And then if you do, are they proportional? So this one is kind of building on itself. If you know one angle in each triangle, and you know the side measures that create those angles, then you can check and see if they're proportional. And if they are, they're similar. If they're not, move on. Last one I check is, do you know all three sides are proportional? And that one's kind of harder to get, so I usually say that one for last. So right here, it looks like I know a couple of different angles. But see, 40 and 50 don't match up. So I think that based on this statement of ABC equals 180, I think they're trying to lead me into finding out what angle C is. So if you know two triangles, you can find the third. So let's look up for angle C. We've got all three angles added to 180. Do some substitution in for 40 and 90. Here's the 40, here's the 90. We combine like terms, and we do the subtraction property of equality to find out that C equals 50. Now if C equals 50, and E equals 50, and B equals 90, and D equals 90, do I have similar triangles? I do. I can mark similar, and then I can say, well, that's angle, angle. I don't need all three angles, I just need two. Angle, 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 angle. So I mark angle, angle on my test, and then it says if they are similar. Notice, this is only if they're similar do you fill out the similarity statement. If you mark not similar, then you had better leave this blank, because they're not similar. But in this instance, they are similar, and we've told why they're similar, and now we're going to fill in the similarity statement. If you'll notice, we start at A, and go to 90, and go to 50. Well, the only angle on the bottom triangle that doesn't have a marker is F. So we have to start at F, because it's the 40-degree angle. And then we go to 90, and then we go to 50. So our answer is going to be FDE. Do not mix up the order on these. I hate giving kids wrong answers when they're not paying attention to the order. The order matters. So now we look at our angles. We look at our answer. This is what I should see on a test. Now, obviously, I'm going to want to see the work to how you found angle 50. Show your work. But you're going to have two problems like this on a test. They're 2-point problems, so they're worth quite a bit. And you must show all your work to get your credit. 0 work shown equals 0 points. You can't just guess similar at AA. I'm not going to take guesses. So, okay, let's look at this one here. What was our steps, our order? We look for two angles. Do I have two angles in this triangle that are congruent? Nope, just the one. So now go on to the next one. Do I have one angle in both triangles? Yes, I have one angle in both triangles. So I've got that done. Now the next thing in those rules, or those steps, was, do I have the sides? Oh, do I have all three sides? No. Do we have two angles? No. We have one angle, but we don't have the side length that make up this angle. We don't have PR. And since we don't have PR, we can't find out if it's a side angle side situation. So we don't have all three sides, we don't have two angles, and we don't have an angle with both sides of the angle. So if this had like a 10 here or a 9 or something, we could go further, but we can't because there's no value here for PR. So our final answer has to be not similar. So the triangles aren't similar. That's how you're going to handle these types of questions. You're going to have to be able to be a master of geometry and figure out if they're similar or not. Okay, now, so we look here. I filled in some of the answers. Are the sides proportional? You look at the, you got to make sure you line up 12 is bigger than 10, right? 18 is bigger than 15. So I have to compare 12 to 18 because it's the longer sides of each piece. And then 10 and 15 match up because they're shorter on each of their respective triangles. And when I reduce down these fractions, I see that 3/2 equals 3/2. And that means that the triangles are similar due to side angle side similarity. So because 10 over 15 and 10 are corresponding and 12 and 18 are corresponding, now we have to move on to look at, they are similar. We mark in they are side angle side. Now we look at our triangle similarity. Now when you're looking at the triangle similarity, you notice A is a part of the short side. And we look over here and we see N, sorry, I misspoke. A is a part of the long side and N is attached to the long side. So we have to start with N when we do our triangle similarity because it's a where we start. A